Today we are going to review or learn some of the key features of quadratics and also graphing higher order equations, or should I say functions. Okay, so our do today is you're going to find the minimum, the maximum, the region of increase, decrease for a function such as the one you see here in the do. Now, our wicker. What is the meaning of the word features? Okay, well, think of this here. If you talk about features, you're talking about the way something looks. Okay? And if you're talking about the way something looks, certain things can be pleasing or they cannot be pleasing. For example, let's just take a look at a very popular game right now. If you were to look at the app called Hoppy Bird, what would you see in that app that would cause it to look pleasing? Okay, so what are the features about that game that make it so attractive that you just want to spend hours playing it? Okay, so can you picture the features of a polynomial? What are the features of a polynomial that, I don't know, cause it to have certain characteristics? All right, well, that's what we're studying for today. The first characteristics that we're going to take a look is x-intercept. What is the x-intercept? Well, an x-intercept is the place where the graph crosses the x-axis. For example, if you take a look right there, that is an x-intercept. That's an x-intercept, and that's an x-intercept. So in this function here, you have three x-intercepts. Okay, now I want you to notice something. If I wanted to know where an x-intercept was, that means the y value would have to be what? Well, think with me here for a second. If I were to look at this here and draw the ordered pair of this here, we could say, okay, let's say this point right there is 2. Okay? That means it would be 2, 0. In other words, if I wanted to find the x-intercept, I would have to plug 0 in for y. And then you just solve for x, and that finds you the x-intercept. Okay, what about the y-intercept? How does the y-intercept happen to work? Well, for the y-intercept, if you want to find the y-intercept, you have to find where it crosses the y-axis. Okay, so for example, here's your y-intercept. And if I want to find that y-intercept, so let's say that y-intercept is, say, has the order pair 0, 11. Okay, 0, 11. Now, if its y-intercept is at 0, 11, notice right here, the x value is what? 0. So if you want to find where it crosses the y-axis, you plug 0 in for x. So over in your Cornell notes, on the left-hand side, I want you to put x-intercept. Okay, so x-intercept. And I want you to make a little note. And your note's going to say this. To find the x-intercept, you plug 0 in for y and solve for x. Okay, now, then I want you to make a little note for y-intercept. To find the y-intercept, you plug 0 in for x and solve for y. Our second characteristic that we're going to look at today is intervals where the graph is increasing, decreasing, or neither increasing nor decreasing. All right, so let's start with increasing. A function is increasing if the region of the domain where the range increases as the domain increases. Okay, again, increasing is the region of the domain where the range increases as the domain increases. All right, so go ahead and pause it if need be and get that down. All right, now let's take a look at what decreasing is. Decreasing is the region of the domain where the domain decreases as the domain increases. Okay, again, it's the region of the domain where the range increases as the domain decreases. And lastly, the constant. The constant is, or should I say, a function is constant. That is when the region of the domain where the range is constant as the domain increases. Okay, so let's take a look at this example here. In this example, I see that I have a function that increases, then it decreases, then it increases. Now, I'm going to concentrate only on the domain, okay? And notice as my domain increases, my range increases, okay? So this function is said to increase in this area from here to here, okay? Now, how are we going to write that as in interval notation? Okay, so here's how we're going to write that as an interval. I'm going to say that the function will increase from negative infinity to negative 2. Okay? So from out here at negative infinity up into this point right there, the function increases. Now, then I notice that the function decreases from here down to there. But we don't write it that way. We say it decreases from negative 2 until you get right there to, let's say that's about a 1. Okay? So I'm going to say it decreases from negative 2 up until it hits about positive 1. Okay? Now, notice at that point the graph increases again. So let's take a look at the domain, and I can see that the domain from 1 all the way to infinity, the graph increases again. So I'm going to put another interval here, so I see it increases from the domain value 1 all the way to positive infinity. All right, now, the only thing we haven't talked about is what is a constant function? What does that mean? Well, let me just give you another example. Let's say I have a function that comes down like this, and then it flattens out. And then maybe it goes down again. Okay, now, that function is constant in this region right here. Okay, so if it's straight across, that means the function is constant. Okay, now let's talk about y-axis symmetry. Now we've already done this. Okay, this is a review here. But for y-axis symmetry, here's your definition. It is when the graph reflects across the y-axis. In other words, your graph is going to look like this graph right here. Okay, notice here's your axis of symmetry, and this side reflects over the y-axis, giving you a graph that looks just like that. So this is y-axis symmetry, when a graph is symmetric to the y-axis. Okay, so what is x-axis symmetry? X-axis symmetry is when a graph reflects across the x-axis. Now, here's an example of a graph that is symmetric to the x-axis. So, notice, here's your x-axis here, here's your graph, and it reflects over it. So what's on the top part of the x-axis looks identical to the bottom. It just reflected over. So, x-axis symmetry. And then, of course, we have origin symmetry. Now, origin symmetry is when the graph reflects across the origin. Okay, so an example of that would be this function. It's a cubic function with the center of the graph, if I could call it that, being right there at the origin. So what we're seeing here is I have a function that goes up like this, and then it goes through the origin right there, and then it goes on up through. So if I were to draw a straight line, okay, through the origin, something like that, you would see a point right there, and I'm going to say that point looks like it's going to be, say, maybe -4 negative 25. Okay? This point right up here where it crossed would be 425. So notice that point is reflected across the origin. All right, so that is symmetry. Our fourth characteristic that we're going to look at today is a relative maximum and minimums. Okay, now sometimes a function will have a maximum or a minimum. When something is relatively max or a relative minimum, that simply means this. So a relative max means it's the highest point in a particular section of the graph. For example, if I were to take a look at this graph right here, okay, if I were to look at this section of the graph right in here, what is the highest point? Well, this is right there. Okay, so that is called the relative maximum. Now, if I want to know the relative minimum, well, the relative minimum is just the lowest point in a particular section of a graph, meaning if we were to take a look at this section of the graph, the lowest point there would be that point right there. Okay, and that would be a relative minimum. Okay, folks, now we're going to do an example using our graphing utility. So use your smartphone, use your app that we put on your smartphone, and I want you to go ahead and follow along with me as we do this example. Okay, we're going to start today by taking a look at some characteristics of this equation. Now, if you take your graphing utility and you're going to enter in x squared minus 6x plus an 8. Okay, so go ahead and pause it, then take your graphing utility and enter in that equation. Again, it was x squared minus 6x plus an 8. Okay, now that you have it in, I want you to pinch your screen until you have something that looks like what's on the screen. Now, we're going to take a look at some characteristics of this. Okay, now we've already defined each of these. So let's just start first of all by looking at the x-intercepts. If you take a look at the x-intercepts, here is your x-intercept right there. I can look there and I see that x-intercept is going to be 2, 0. Now notice, when y is 0, x is 2. That means that's your x-intercept. My second x-intercept is right there. So that would be 4, 0. Again, notice what is 0. Y is 0. So those are x-intercepts. Those are two characteristics of this graph. Now, let's take a look at a third characteristic. The third characteristic is the y-intercept. There is the y-intercept. Now, notice the y-intercept, 0, 8. Notice what is 0 this time. Yes, x is 0. All right, now the next thing I want to do is we're going to take a look at the minimum value. This has a minimum value because if you'll notice, see here, right here, it's a minimum right there. It's the smallest point on the graph. It's a minimum. Now notice that minimum is 3, negative 1. Notice this function decreases until it gets to this point right here. Okay, so we can say that the function decreases. Now we're just taking a look at the x here. At the x-axis, notice the function decreases from, and we're going to say from way over here, which could be like, I don't know, negative infinity, up until it hits this point right there at x equals 3. So it will be decreasing from negative infinity until it hits negative 3. Now, in that point, it starts increasing. So from 3 to infinity, it will increase. Okay, so there are just a few of the characteristics of this. So where does it increase? Where does it decrease? Where does it cross the x-axis? Where does it cross the y-axis? Well, folks, that's about a wrap for today. Next time when we get together, we're going to be taking a look at finding these key features using a graphing calculator on an activity. So, I guess I'll see you in class.